So we're talking about trig functions of general angles. So remember that when we graph something, we want to graph it in standard position, which tells us what? What has to be where in standard position? Which parts have to go where? What are the two sides that we have for an angle? Might need to flip back in our notes. That's okay. It tells you one of them in the definition. The terminal side, right? The terminal side is the one that rotates, yes? And it rotates which direction? Counterclockwise. And then what's the other one called? No. It's another word for starting. Not beginning. Initial, yeah. So it's our initial side. So remember that our initial side has to be on our positive x-axis. Our vertex has to be at the origin. And then our terminal side is going to be the one that rotates. Agreed? Okay with that? So, in this case, we're looking at a theta. And we want to be able to find our trig functions for that theta. Okay? Again, what do our trig functions relate? How do we get our ratios for trig functions? What's the one thing that y'all tend to usually remember from geometry? What's the fun little thing? What is it? SOHCAHTOA. So that means that sine is what over what? Opposite over hypotenuse, which are what? What is opposite? What is hypotenuse? What do those mean? They're what on a triangle? The sides of a triangle, right? And so what do I take sine of, though? Theta, which is a what of a triangle? An angle. So our trig functions relate angles to sides of a triangle. Are we all okay with that? Yes? Do I have a triangle right now in my pretty picture? Do I have one drawn in my pretty picture? Yes, no, maybe? So if I drew my triangle like this, do I want to use that triangle? Why not?
It's not right.
It's not a right triangle? It's wrong? Where might we draw it instead? Down? Because now, is that a right triangle? Pretending that that is straight up and down. Mine's a little off, but that's okay. Are y'all with me? Yes?
Yeah.
Okay? So, notice that I'm going to use this angle right here as our theta, because its relationship is still going to be similar to this theta over here. Okay? So, what is the bottom length of that leg? How far over have we gone? Just in like general. It's going to be a variable.
I forgot the question.
So like how far is this, so from my vertex to the end of my leg, right? Angle. What's that length right there? What information do they give us? They give us a point, right? What does the point tell us? A point gives us two values, right? What do those values represent? X and Y, but what do X and Y represent? What direction does X go? Left and right. So it tells you your horizontal distance, yes. And what direction does y go? Up and down. So that tells us our vertical distance. Agreed? So for my bottom leg, okay, which direction have we gone? Left. Yes. So which one did we tell us tells us how far we've gone left and right? X. So this length would be whatever x is. Now for my left leg, what direction is it going? Up and down. So what would give me the length of that leg? Which one of these gives me up and down? Y. And then my hypotenuse would be R. That's going to be the length of this right here. Does that make sense? Yes? Which is then how they get all of these. Notice that sine of theta equals, well, if I'm talking about this little angle in the corner, remember sine is opposite, which is y, over hypotenuse, which is r. Cosine is adjacent, which is x, over hypotenuse, which is r. And then lastly, tangent is opposite, which is y, over adjacent, which is x. And then remember, our other three are just our reciprocal functions, so we just flip our original three. Are y'all okay with that? Yeah? And so this helps us to be able to find any type of trig function of angles. So sometimes they might not give us an angle, they're just going to give us some point, and we're going to use these formulas to find sine, cosine, and tangent, because if I don't have an angle, I can't take sine of 42 degrees. If I don't know what that angle is, I can't take sine of that. And so that's why we have to use our ratios of our sides instead. Yes? Okay, let's look at an example. It says, let negative 3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. What might it be helpful to do? Graph it. Draw a pretty picture. Now, what quadrant is negative 3, 4 going to be in?
2.
The second. That would go left because it's negative x, and up because it's a positive y. Again, remember that this is our terminal side, so that would be our angle right there. Agreed? But again, if I draw my triangle, where do we want to draw our triangle to? The negative x-axis. That way we have a right triangle. Agreed? So what is our bottom side or leg? Maybe negative 3, because that's our x value. What's our left side going to be? 4. And then how do I find my hypotenuse? The Pythagorean theorem. So remember that your hypotenuse is going to be your r value. And remember that a squared plus b squared equals r squared, but basically we end up just taking the square root, and our two sides are x and y. So for us, in this problem, what is our x value? Negative 3. And what is our y value? 4. So we end up with 9 plus 16, which is 25, which is 5. So we have a 3, 4, 5 triangle, which makes sense. So now do we have enough information to find sine, cosine, and tangent? Yep. So what would our sine of theta be? Opposite. So what's our opposite? 4. hypotenuse, which is 5. Our cosine is going to be what? Which is, yep. And then lastly, tangent is what? Opposite over adjacent, so we get. So do we all see how we got all of those values? Yes? So if I'm in my second quadrant, will my bottom length always be negative?
If it ends up where there's a negative on the bottom, you have to write it like that.
Like that? No, you can write the negative out to the front or on top. It doesn't matter. Just as long as there's a negative somewhere. So what did we say? If I'm in my second quadrant, will my bottom length always be negative? Yes. Will my side length always be positive?
Yes.
Yes. Okay. So does that mean that in my second quadrant, sine is going to be positive and cosine and tangent will always be negative? Agreed? Alright. So if we think about that, so we said that in my second quadrant, x is negative and y is positive. So which of our trig functions was the only one that was positive? Sine was positive. Agreed? Now, in my first quadrant, what's positive and what's negative? For my x and my y. They're both positive. So which one of my trig functions will be positive? All of them. Yes? So in my third quadrant, which are negative? Both are negative. So what does that mean sine will be? Is r negative or positive? R is a distance, right? R is your hypotenuse.
Oh, that's right.
Can I take the square root of a negative number? Can I end up with a negative if I take the square root of a positive number? No. So R always has to be positive. So if I have a negative divided by a positive, what's sine going to be? Negative. If I have a negative divided by a positive, what's cosine going to be? Negative. But on tangent, if I have a negative divided by a negative, what does tangent end up being? Positive. So tangent is going to be our only positive function. And then what about in my fourth quadrant? Is x positive? Yes. Is a y positive? No. So which one of my trig functions is going to be positive? Cosine. So the way that we can remember which one is positive is a smart trig class. Are you with me? Because sometimes it'll be important for us to know which of my trig functions is positive, which of my trig functions is negative. And we're about to look at an example of why. So they give us that tangent of theta is negative 5/4. And then they tell us that cosine of theta is positive, and they ask us to find sine and secant. So this time, do they give us a point? Just flat.
Sorry.
Do they give us a point? Like they did last time? No. But what can we find from our tangent? What is tangent? Negative 5/4, but in general, what is tangent? Opposite over adjacent, which for us was y over x, right? So So we know what our x and our y are, so we can still draw our pretty triangle. Agreed? Yes? But what do we have to figure out? Our r, but what else? If I want to draw a picture, where it is, right? So am I going to be in my first quadrant? No, because tangent is negative. So in what quadrant is tangent negative? Second and fourth. So how do I know which one of those it is? Do they give us any other information?
Yeah.
Which means it has to be positive. So where is cosine positive?
4.
1 and 4. Well, the only place that both of those happens is in our 4. Are we okay with that? Yes? So now we can draw a picture because we know what quadrant it's in. And again, I'm going to draw my triangle. Do we know two sides to our triangle? Yeah, because they tell us what tangent is. So again, remember that our trig functions relate an angle to the sides of our triangle. So tangent is what over what? Yes, but as far as our sides of a triangle. Which two sides is tangent? Opposite over adjacent. So opposite of this would be my right side. So that would be 5. And adjacent would be 4. Well, which one of those gets the negative? Why? Correct. So we're going down, so it would have to be negative. So then what do we need to find? The hypotenuse. So remember that our hypotenuse is our r value. Agreed? And we get that that is the square root of x squared plus y squared. So r equals the square root of 16 plus 25, which is the square root of 41. Can we reduce that? Nope. So that's going to be my r value. And then this time they ask us to find sine and secant. So sine is going to be opposite over hypotenuse. So which one of our values is opposite? -5 over our hypotenuse, which we said is also our r, so the square root of 41. Do I want to leave it like that? What do we generally have to do? Do we like square roots in the bottom? No. So what do we need to do? Yes, sorry, multiply by square root of 41 over the square root of 41. So we end up with -5 square roots of 41 over 41. Can I reduce 5 over 41? Nope. So then that's my answer. Now, secant is the reciprocal of what? Cosine. So that means that it is what over what? Agreed? Remember, it's the opposite, basically, of our cosine. So what's our hypotenuse in this case? And then what is our adjacent? 4. Now, does it make sense that my secant would have to be positive? So secant, we just said, is the reciprocal cosine, right? reciprocal also going to have to be positive? Yeah, so when we talk about sine, cosine, and tangent here, if sine is positive, cosecant will also have to be positive. If tangent is positive, cotangent will also have to be positive. And if cosine is positive, secant will also have to be positive. Does that make sense? Like the reciprocal that goes along with it would also have to be positive in that. So it makes sense that sine will be negative, but secant would be positive. Questions on that? Yes, no? Maybe so? Alright, so for us, remember we talked about last week some of our special angles. Yes? Okay. So we want to kind of do this same process, but with some of our special angles. In order to be able to do that, we need to remind ourselves of some of our special triangles. So what were the two special triangles that we talked about last week? A 30, 60, 90, and a 45, 45, 90. So if both of my angles are 45, what is going to have to be true about the sides? Which ones will be equal? The two legs. Yeah. Ones are not the hypotenuse, yes? So those would both have to be x. Agreed? Okay. Now, if these are both x, how can I find my hypotenuse? Equals square. So how many x squares do I have? And then what do we do? Well, what is the square root of x squared? Can I simplify the square root of 2 though? Nope. So those are our formulas. When I have a 45, 45, 90, it's going to be x squared root of 2. And those are always going to be the relationship because remember that anytime I have a 45, 45, 90, the sides are going to have to be similar to any of my other triangles with the same angle lengths. Yes? So that's why the ratios will always be the same. Now, on our other one, let's say this is 30 and this is 60. Are our side lengths going to be the same on this one? Not quite. So let's go ahead and label our bottom length. We're still going to label as x. Do we remember what our side length is? Yes, if I'm talking about like on a coordinate plane. But from geometry, we have formulas that give us each of the side lengths for a 30, 60, 90 triangle. Do you remember what it is? No? It's going to be x square root of 3. And again, if we wanted to go through, we could do x squared plus x square root of 3 all squared, and take the square root of that, and we end up with 2x. We all with me? And we need to remember these because we're going to have to use it on our next thing. Again, we found sine, cosine, and tangent, right? For some of our angles that were just general ones. Now we want to find or remind ourselves of what they are for these specific angles. So, before when we were looking at our formulas, we labeled our hypotenuse as what? R. Okay? Now, for our purposes, okay, we want our hypotenuse to just be 1. So when we are dealing with the unit circle, like I said, we're gearing up for the unit circle. We're going to put all of this on our unit circle. We allow our radius to be 1. Because again, remember that for these formulas, these ratios have to be the same, but we can pick one of them to be whatever we want it to be. Does that make sense? And so that's why we go ahead and just pick the hypotenuse or our radius to be 1. And if you can't quite see it, pretending that that's a nice pretty circle. This is our circle, right? If we're rotating. So that's why this would be our hypotenuse for both of these would be our radius. And so that's why both of those are 1. Does that make sense? Are you with me? Okay. So now, because our ratios have to be the same, if we go ahead and label, so let's say this is our right angle. This one's going to be our 45, and this one's going to be our 30, and our 60. Yes? If I've determined one of my values, can I use those formulas now for my other values? Yes? Okay. So remember that for this one, this was x, and this was x square root of 2. Agreed? Well, if I set this equal to 1, what does that mean that x is? How would I solve for x? Not x. And again, do we like to leave our square roots in the bottom? No. So we end up with the square root of 2 over the square root of 2. Which means that both of these sides would have to be square root of 2 over 2. Agreed? Do y'all see how I got all of those values? Again, right now, we're just trying to figure out what our sines and cosines of each of those angles are. We're not going to have to do this every time. Like, this is just for us to figure out what sine and cosine of 45 and 30 and 60 are. After that, we just memorize it. But I want you to know where we get those values from. Does that make sense? Okay. So, if I'm looking for the sine of 45 degrees, what is sine? Opposite over hypotenuse. Well, what is my hypotenuse? 1. So if I take anything and divide it by 1, what's it going to be? Just the other thing, right? So I just end up with the square root of 2 over 2. And then what about cosine of 45? It would be adjacent, which also happens to be square root of 2 over 2, over hypotenuse. So what do we also get? Square root of 2 over 2. And like I said, once we have those, we can just memorize them. You're not going to have to write out that triangle every single time. So we just need to kind of have those memorized. But this is where they come from. So if you ever wondered why this sine and cosine of 45 is square root of 2 over 2, it comes from our special triangles. Now, what were our formulas for our 30, 60, 90? X square roots of 3 and 2x. So if 2x equals 1, what does x have to be? So that means that this would be 1/2, and this would be times the square root of 3. So we're just going to go ahead and write that as a fraction. So the square root of 3 over 2. Yes? So far, so good. So then, sine of 60 degrees would be opposite over hypotenuse. So what do we end up with? Just the opposite one. What about cosine of 60 degrees? So we just end up with 1/2. Be careful when we're doing our sine of 30. We're going to use that top angle instead. So what would our opposite be? 1/2. And then what would our adjacent be? The square root of 3 over 2. So that's why our 30 and 60 are just flipped, because they come from the same triangle. And so they're just the opposite one. And again, are you going to have to draw this out really ever in the future? No. But I want you to see where they come from. But you do need to have them memorized. So again, those are your special angles. So we need to have sine and cosine memorized for 30, 45, and 60 degrees. Because tomorrow we're going to look at some reference angles where we're going to need to use these values. That make sense? Yes. Alright. So that's where we are going to stop for today.